So we're looking at a new overview of the machine. First we'll look at the patches. Each patch is being cut by a laser module here, of which we have 8, from a piece of wool fabric. Each cut patch falls onto a conveyor belt and is then shown to a machine vision system, which helps the pick and place unit here pick 8 patches per production cycle. On the other side we have the label hopper, and this is a slightly different system. So we're using a hopper because it turns out getting labels in a packaging format suitable for this kind of production velocity and reliability turns out to be not something you would want to rely on. So instead what we'll do is sort this, like for example waste sorting systems we are working already. So this conveyor belt will show the labels to a machine vision system, which will then mark the labels that are suitable for use, so no overlap, right side up for example. And from this surface then will the pick and place unit take those suitable labels. And the pick and place machines will assemble the scapulars on this red conveyor belt, and starting at the top left side where the patches are placed in the correct positions, then here we have a system to apply strings, and after that the final stage applies the labels, and after that there's 2 heating elements to melt together the scapulars making them ready for use. Completed scapulars will be ejected here, and we've kept the space and option to add a stage here to package the scapulars in specific amounts, for example 50 per bag or box. So there's a lot of extra systems and complexity, but most of the things are geared to make it possible to produce these scapulars quite quickly. We need 1 scapular per second on average, and we're doing this by producing 4 at a time, making each production step have a time budget of 4 seconds. To do so, for example, these pick and place machines need to move quite quickly and have been designed to be very compact and lightweight, and also to eliminate a lot of the moving around. So that's why we have 8 individual units here. Each of these units can pick 1 label, and that means that we only have to do local motions here to pick up the labels, and then go to a drop-off site, drop off 4 at a time, and then drop off 4 at a time here as well. And that makes for the most optimal strategy. These units themselves, the pick and place units, are identical between the label and the patches side, and they use needles to hold on to a patch. Let me show it a little bit in detail. And it's a pretty standard solution in fabric handling. What makes these units unique is that they are meant to be both very light, very compact, and last a long time. And that last bit is for example an improvement on the current units by having this as a continuous rotating system. So the normal needle grippers, they use an oscillating system, for example by a pressure cylinder or by a solenoid, and those load reversals there, that's usually the part that it's usually what makes these things wear out quickly. And what we're doing here is make these load reversals very gentle, and by having by translating a continuous rotating motion. So that will the intent here is that these units last the entire lifetime of the machine, and that applies for most of the parts designed here. That the machine is meant to last for at least the minimum time before a major revision is 5 years. And major revision would be consists mostly of replacing bearings, for example. Another interesting part here is the string management. So in terms of volume, the strings used in the scapulars are actually the biggest parts. So that's why we have these 8 individual rolls, each of them connected to a lever here. And this lever shown here, it rotates on this part and can swing up and down at the other side. This decouples the condition of this decouples the action of applying the string onto the scapular from, for example, how full the drum holding the string is, or anything basically, variations in thickness or elasticity. The only thing that these drums do is have a servo drive, and based on an input signal, the angle of this arm, they will either increase or decrease the tension by unwinding or winding this spool. So that makes that this whole system is self-adjusting, and that's a theme that's basically repeating everywhere in this process. All of the machinery, all of the devices here are designed to be completely self-adjusting, and after initially assembling this, there should be very little adjusting necessary before we can start production. Another addition since the last overview is the filter box here, which is basically a large filter similar to what's used in clean rooms and some other industrial installations. Fans take out the air and the dirty air, and specifically the fumes from the laser cutter go in here. And the intention here is that we create a very good working environment. It should be that the air coming out of the machine is of better quality than what went into the machine. Lastly, we're using a large touchscreen to show status information. We have a lot of sensors working on the machine to show not only the sensor readings, but the production targets, the upcoming maintenance, for example, and basically any related information to production. For maintenance, we can also show the diagrams, the wiring diagrams, the CAD designs for the individual parts to locate sensors, to locate replacement parts. So we'll use this as a central information hub for the machine. And the same system can be accessed over the internet, for example, if necessary. So yeah, that's a quick tour of the machine, and well, I hope it's interesting, and we'll do another update soon, I think.